So let's pretend that the top of this table is at the bottom of the ocean. This is the ocean floor, the bottom of the ocean. There's lots of fish over here, there's water here, okay? What is underneath of the ocean crust? Well, down here, this would be the mantle or the asthenosphere. What is happening in the asthenosphere? There are convection currents happening in the asthenosphere. Now with these convection currents happening, let's say the convection current is spinning in this direction, it will cause that this plate to move this direction. Think of the convection currents like a conveyor belt that's constantly spinning. Whatever is on top of that conveyor belt is going to move with that conveyor belt. Okay, again, we have our convection currents. If I have something on top of that convection current or the conveyor belt, as it spins around, it's going to be moving that item. So if the convection currents are happening underneath this ocean crust, it's going to slowly be pulling both of these pieces of ocean crust away from each other. With the convection currents pulling both of these ocean crusts apart, it creates a crack between them. Now with that crack causes a hole, which then pushes the new molten material from inside of the mantle or the asthenosphere up through that crack. It will create pillow lava, which then builds up, and builds a mountain range in the middle of the ocean. We call this mountain range the mid-ocean ridge. Now at this mid-ocean ridge, this is where the brand new crust is created. It's slowly pushed up from the convection currents that are happening underneath and pushed up through that crack, creating that new crust. And then when that new crust keeps building up and building up, it slowly is adding new crust at the mid-ocean ridge. Now, it pushes everything up at the same rate. We don't have one side going faster than the other. So since the convection currents are pushing at the same rate, both sides are being pulled out at an equal rate. You can see how the stripes on both sides are coming out at the same time. You can also notice that the stripes are the same thickness. So the magnetic stripe on this side will be the same size as the magnetic stripe on this side because they're both being pulled out at the same rate. Sometimes it takes a little bit longer, like this long stripe, for the poles to flip. Sometimes it's not as long, as you can see by this thin strip. But over time, you will see that those stripes will match on both sides. So you're asking yourself, if it keeps expanding at the mid-ocean ridge, does that mean the Earth is just getting bigger? No, it's not. What happens is, eventually, it hits a continental plate. Let's pretend this is a continental plate, okay? And then when it hits that continental plate, the continental plate is less dense than the more dense oceanic plate. So what happens is, this oceanic plate sinks underneath the continental plate, and it keeps going down underneath and goes back into convection currents. Once it goes underneath of the continental crust, it goes back into the mantle and is recycled and eventually may come back out in the mid-ocean ridge. So this is what we call a subduction zone. Think of a submarine. A submarine goes down under. A subduction zone has crust go down under. The oceanic crust goes underneath the continental crust. So this is continental crust. Where my paper is, this is oceanic crust. And it goes back under, back into the mantle. Now, sometimes when this subduction zone happens, it can create volcanoes that are on the continents. This happens in South America and many other places around the world. So when these two crusts collide, one goes underneath the other. The one that goes under is the one that is more dense, because if it is more dense, it is more compact together and it is going to sink due to gravity. Now the one that is more dense, if it's an oceanic crust, like my paper is oceanic crust colliding with a continental crust, then the oceanic crust will go under because it is more dense than the continental crust. If you have two oceanic crusts colliding, the older one will subduct under the newer crust. There at a subduction zone, there is old crust, because remember, all the way over here, the new crust is coming out of the mid-ocean ridge. This is our mid-ocean ridge. M-O-R, mid-ocean ridge. It creates more crust. Mid-ocean ridge, M-O-R, more crust. Mid-ocean ridge. This is our deep ocean trench is occurring at a subduction zone. A deep ocean trench is our feature, and our process that happens here is subduction. Subduction is when it sinks down, and when it sinks down, it creates this big giant valley, and that valley is what we call a deep ocean trench. I've always told my students to remember what a deep ocean trench is the abbreviation DOT, deep ocean trench. And at a deep ocean trench is where the crust is really old. All the way at the mid-ocean ridge on the other side in the middle of the ocean, that is where the mid-ocean ridge is, where there's more crust. Mid-ocean ridge, more crust. Deep ocean trench, that spells dot. That doesn't do anything for me, Mr. Jones. What are you talking about? I have a friend. Her grandma's name is Dot. She's old, she's crusty, old crust, and the old crust goes underground eventually. So this is the old crust that goes down under. It's not a real story, but it helps students remember it. Mid-ocean ridge is where more crust is created. New crust is down here. Old crust is down here.